How do you find an empirical formula? You can do it from elemental analysis. You can look at the mass of elements that combine to form the compound, or you can take the compound and separate it into its elements and measure the masses of those. We're going to do this in experiment 3 with zinc and iodide. You can also calculate an empirical formula from the percent composition. Again, just like we talked about in the previous couple of slides, the empirical formula gives us a ratio of atoms or a ratio of moles, not a ratio of masses. So we need to deal with moles here. This is one of those chemistry problems that it's helpful to learn some steps for. And there's not too many of them. But the first thing you're going to do is start with writing the masses of each element that are present. Sometimes they'll say, it contains 5 grams of this. You just write it down. Other times they'll give you a percentage. And you're like, Well, that's another situation where you get to choose the sample size. If you choose 100 grams, the mass of the element is the same as the percentage. So you just take off the percent sign and write G. Write down the masses of each element. Convert the masses to moles. And then divide the moles of each element by the smallest number of moles. We need the ratio of moles in the compound. Sometimes this gives us a really nice whole number. Other times it gives us kind of a messy number and we have to figure out what to do. This is my rule of thumb, because if you're doing this with real data, it's not going to come out perfectly. But we know that there is small whole number ratios of elements in a compound. So if the number you get is within 0.2 of a whole number, you can round it. But if it's like 7.3, you can't round that to 7. Or if it's 2.5, you can't round that. So if the subscripts are not whole numbers, then you need to multiply all of them until you get whole numbers. If you understand the fractional equivalent of fractions, or the decimal equivalent of fractions, like 0.5 is 1/2, right? So if it ends in 0.5 or close to that and I multiply by 2, I'm going to get a whole number. There's this nice table. The other thing that works really well is start by multiplying by 2. Just that one that's not a whole number. If that doesn't work, start over again with 3 and 4, and usually you don't have to go any further than that. Okay, let's do one. A sample of a compound is decomposed in the lab and produces 165 grams of carbon, 27.8 grams of hydrogen, and 220.2 grams of oxygen. Calculate the empirical formula of the compound. So we need the mass of each element. They gave it to us. Mass of carbon, mass of hydrogen, mass of oxygen. So we're going to write those down. 165 grams of carbon and 27.8 grams of hydrogen and 220.2 grams of oxygen. That's step 1. Step 2 is convert the masses to moles. These are all elements, so we don't have to calculate molar masses. They are just on the periodic table. So the molar mass for carbon is 12.01. 1 mole of carbon is 12.01 grams. 1 mole of hydrogen, 1.008 grams of hydrogen. Oxygen, 1 mole of oxygen is 16.00 grams of oxygen. Again, oxygen is in a compound here, so we're not going to multiply by 2. So now we have some math to do. So this is giving me 13.73. You do not want to round too much. So this one had 3 sig figs. So this number, I should keep at least 3 sig figs. And I should also write down the correct number. It's 7.3. I like to keep 2. 27.8. 27.579 moles of hydrogen. So these are the moles in this sample of this compound. But we need our mole ratios. The subscripts in a chemical formula are 1 or larger, and so we want to pick the smallest one, and we're going to divide all of them by the smallest one. So this is the smallest one, right? 13.73 compared to 13.76. So this one's going to be divided by itself. That's going to end up with, if you want to put the units in here, well, let's not. That's just a ratio of 1.